Welcome to Super Kamioka, a subterranean Japanese neutrino detection chamber.
Japan is rewriting the laws of what's possible by drilling out the heart of a mountain, and the whole world can't believe it. Hidden deep inside, a massive underground chamber is under construction, big enough to hold entire skyscrapers. But this is more than a crazy construction spree. Scientists are using it to unravel the ghostly secrets of neutrinos. We've got mind-boggling tunnels, super pure water, and a big question. Why does Japan dare shake the earth to peer into the unknown? Unprecedented scale of construction. In a mountainous region of Japan, one of the most breathtaking feats of modern engineering is taking shape. Deep beneath the rugged terrain, engineers and scientists are working tirelessly to carve out a vast underground cavity set to become the largest of its kind in the world. This towering cylinder, planned at over 220 feet across and equally tall, will house an enormous tank to hold ultra-pure water. The entire project demands a level of precision and safety unlike any typical construction job. Every step involves specialized excavation methods using heavy drilling equipment and careful rock analysis to guard against dangerous fractures. Over 600 anchors will stabilize the rocky ceiling, maintaining a secure environment for workers and the sensitive instruments that will soon line the walls. The operation also requires new roads, power lines, and water systems, all built to support this unprecedented endeavor. Beyond sheer size, this labyrinth of tunnels and chambers stands apart for its high-stakes mission. Researchers plan to fill the immense tank with thousands of tons of purified water for cutting-edge neutrino experiments, aiming to uncover cosmic mysteries by tracking faint signals hidden within these particles. To achieve this, more than 500 researchers from around the globe unified their expertise, pooling time, money, and passion across years of planning and construction. While technical hurdles remain, the team believes this giant undertaking will push science forward in dramatic ways. With each tunnel carved and anchor drilled, human ingenuity proves unstoppable. This structure symbolizes not merely size, but a leap toward unlocking the universe's hidden truths. The purpose: neutrino detection. The elusive neutrino is one of nature's greatest puzzles. Known as ghost particles, they pass through matter with barely a trace, making them extremely tough to detect. Yet they hold vital clues about the universe, from how stars burn to why galaxies form as they do. By studying neutrinos, scientists can test fundamental theories, explore exploding stars, and possibly uncover secrets about the building blocks of reality. To capture these slippery particles, researchers are building massive detectors deep underground or inside mountains.
So one of these could see a flashlight on Earth from the moon.
Yes, right.
Wow.
Japan's ambitious project, Hyper Kamiokande, is carving out a gigantic chamber beneath Mount Nugo to hold a vast tank of ultra-pure water. When neutrinos strike the water, they produce faint flashes of light known as Cherenkov radiation. Photomultiplier tubes lining the tank's walls record these fleeting signals, helping scientists pinpoint each neutrino event with unmatched precision. The purpose behind this enormous effort is to unravel the neutrino's hidden nature. Scientists hope to discover why these particles hold tiny masses, whether they change flavors as they travel, and how they might connect to mysteries like antimatter.
We accumulated enough data to make one conclusion, that is, neutrino oscillations and anti-neutrino oscillations may be different.
By observing neutrino interactions with higher accuracy, researchers can refine existing theories or find cracks that might lead to brand new physics. Each detection is a rare glimpse into processes normally invisible to us. Neutrino experiments have already helped confirm vital concepts, including oscillations between different types, which earned Nobel recognition. As detectors grow larger and more sensitive, they could reveal answers about the universe's earliest moments and point us toward uncharted realms of physics. With every neutrino captured, humanity edges closer to cosmic truth. Why inside a mountain? Mountains are not just scenic wonders. They also provide the perfect hiding spot for cutting-edge science. Building a massive neutrino detector inside a mountain offers a natural fortress, where thick layers of rock block out unwanted interference from cosmic rays and other particles. This shield is crucial because neutrinos are ghostly and rarely interact with matter. Detecting them takes extremely sensitive equipment that can be overwhelmed in ordinary environments. Deep underground, these detectors have a better chance of capturing those faint flashes when neutrinos interact with water molecules. Another reason for choosing a mountain like Japan's Mount Nugo is stability. Rock formations there, such as Haida gneiss, are exceptionally strong, reducing the risk of collapses. This allows scientists to carve out enormous cavities, some as tall as skyscrapers, without worrying about cracks or cave-ins. The calmer conditions underground also maintain a steady temperature, helping the delicate sensors function with minimal fluctuation. Embedding thousands of photomultiplier tubes in the cavern walls is easier when conditions are stable. Any shaking on the surface can ruin precise measurements, and a well-chosen mountain adds an extra layer of protection. Finally, the watery environment inside such detectors is a powerful asset. The enormous reservoir of ultra-pure water amplifies neutrino interactions, making them easier to spot. By placing this reservoir inside a mountain, scientists ensure it stays undisturbed by vibrations and outside contaminants, preserving its unmatched purity. Ultra-pure water tank. Inside Japan's towering mountain project, one detail stands out: the enormous tank of ultra-pure water set to fill its core. This shimmering reservoir is no ordinary pool. It's a place where science and engineering meet in spectacular fashion. The water is so purified that it can slowly dissolve metal objects. Indeed, a dropped hammer once emerged hollowed out, leaving only a thin shell. Such extraordinary purity is key to detecting ghostly neutrinos, because even the smallest contamination could hide their faint signals. So why go through the trouble of filtering water until it is beyond drinkable? Neutrinos only show themselves in rare interactions, creating subtle light flashes when they hit water molecules.
We work 24 hours, 365 days, maybe not 24 hours. I sleep sometimes, but then if you are lucky, maybe 1 or 2 neutrinos interact sometimes.
Even a stray speck of dust could generate misleading data. By keeping the tank free of impurities, scientists ensure that any light they see stands a better chance of revealing these elusive particles. Called hyperkamiokande, this detector will hold hundreds of thousands of tons of water. Within its vast darkness, sensitive sensors watch every corner, ready to spot the slightest burst of light. The tank's immense volume multiplies the odds of neutrino collisions, offering researchers a window into distant cosmic processes. When these ghostly visitors show up, they might carry secrets from exploding stars or even the sun's core. Global collaboration. Neutrino research is an incredible example of how scientists from all over the world can come together to solve deep cosmic mysteries. The massive underground tank under Mount Nugo in Japan, for instance, is backed by a large network of experts. Over 560 researchers from 101 institutions across 21 countries have joined forces to shape this mind-boggling facility. They pool their knowledge and resources, leveraging each other's strengths and insights to push forward on one of science's hardest fronts. But Japan's project isn't the only place that unites global talent. Collaborations like IceCube in Antarctica, Boraxino in Italy, and Baikal GVD in Russia are also forging common ground. Each one adds a fresh perspective or unique method, creating a rich tapestry of shared data and breakthroughs. Researchers must zoom across continents to attend conferences, host video calls to trade ideas, and split huge budgets from various funding agencies. This synergy allows every site to learn faster than if they worked alone. Even though neutrino studies focus on the hidden building blocks of the universe, progress depends on open communication and shared passion. The scale of these underground detectors would be impossible without the global community. In time, these alliances may show us the first glimpses of the universe's origins or unlock secrets that change physics forever. Above all, these projects are a shining example of what unity can achieve. Language barriers, cultural differences, and distance fade away when there is a single goal: gathering the truth behind these ghostly messengers from outer space. These multinational efforts keep humanity moving forward together. Incredible engineering challenges. In Japan's quest to build the largest underground neutrino detector, engineers face challenges few have ever tackled. They must excavate a vast chamber 2,000 feet beneath Mount Nugo, ensuring the mountain stays stable throughout the process. Creating a cylinder over 220 feet wide and nearly as tall requires countless calculations and specialized drilling rigs. Each blast or excavation pass must be planned so the rock does not crack in unexpected ways. Over 600 anchors secure the ceiling, preventing deadly collapses. Additionally, heavy machinery has to be driven deep through narrow passageways, a process slowed by tight corners and uneven rock. Completing the main access tunnel alone took 9 months of tedious effort, with teams assessing every inch of excavated stone. They study the mountain's geologic layers and monitor microseismic activity around the clock. The workforce installed advanced drainage systems and strong support structures to keep water infiltration under control, given the massive weight of the rock overhead. Coordinating these tasks involves hundreds of workers, each trained in special safety measures.
We're standing here at the entrance of the tunnel that leads to the Super Kamiokande detector. It's about 2,000 meters down this tunnel and to the left.
After the chamber is dug out, a second hurdle emerges, fitting the cavern with thousands of sensitive sensors and eventually filling it with ultra-pure water. Any slight deviation in shape or alignment can throw off the exact detection necessary for neutrino research. On top of that, earthquakes remain a constant fear in this region. Yet, despite the risks, teams press on, forging stronger solutions at every turn. Their success will redefine what can be achieved in extreme underground construction. When human ambition meets science, the results can defy limits. Cost and timeline. The massive neutrino detector taking shape beneath Mount Nugo in Japan is set to cost about $600 million. Over 550 researchers from 101 institutions in 21 countries are involved, sharing expenses for excavation, advanced gear, and specialized upkeep. This global partnership reduces financial risk while driving scientific progress. The result could be breakthroughs in understanding neutrinos, one of nature's most puzzling particles. Work started in 2020 with a 315-foot tunnel and deep borehole to check rock stability. By May 2021, crews began drilling the main access, which took 9 months to reach the dome's center. A bypass tunnel followed for equipment installation. Excavation of the main cavern started in November 2022 and runs through 2024. Each phase hinges on slow, careful digging to avoid collapses, demanding precision methods and constant monitoring of geological conditions. Once excavation ends, crews will install thousands of sensitive sensors and reinforce the walls. In 2025, they plan to clad the interior to handle the mountain's weight. Next, 260,000 tons of ultra-pure water will fill the space, a process that may take months. Even after filling, extra time is needed to purify the water to strict standards. By 2027, scientists hope to begin capturing data, sealing years of construction into groundbreaking discoveries.
Here we have 11,129 PMTs. It's really very sensitive photosensor.
The high cost and lengthy timeline reflect the difficulty of underground physics. Building such a giant detector amid seismic threats demands constant checks and specialized methods. Yet experts agree the payoff could be immense, revealing neutrino secrets that answer fundamental questions about stars, matter, and our cosmic origins. Scientific importance. Neutrinos are ghostly particles. they pass through matter almost unnoticed, making them ideal messengers from supernovas and star cores. Because they rarely interact with ordinary matter, capturing just a few reveals hidden truths about how the universe was born, how stars explode, and even how black holes might form. This is why Japan's massive plan beneath Mount Nugo holds immense scientific value. By placing the detector deep underground, scientists block out cosmic rays and other noise. As a result, any faint flashes of light in the ultra-pure water likely come from neutrinos, signaling rare yet crucial interactions that could revolutionize physics. These fleeting signals offer clues about happenings across the universe and illuminate key physics questions.
Because neutrinos are so numerous out there and they play an essential role in many phenomena like supernova explosions or the formation of galaxies or the life, birth, and death of stars.
Researchers also study how neutrinos switch flavors, a feature hinting at physics beyond the standard model. Past experiments have yielded Nobel-winning results, and hopes remain high for this venture. New detectors promise deeper insights and new physics. The experiment seeks signs of proton decay that could unite separate areas of physics under a single theory. Such a discovery would reshape our view of matter. By scaling up detector size, scientists boost the odds of spotting elusive events and capturing more neutrinos than ever. This research may open new frontiers in astrophysics. The scientific community benefits from global data sharing. Researchers from dozens of countries collaborate, refining techniques and advancing instrumentation. These global networks accelerate breakthroughs that might otherwise take decades. Each neutrino detection is a small piece of a larger puzzle, bringing humanity closer to cosmic insights. Japan's project leads this worldwide charge into the unknown. Previous successes. Japan's earlier neutrino experiments have a storied history of game-changing discoveries, paving the way for the Colossal project underway beneath Mount Nugo.
The neutrino experiment is very difficult, and only a few experiments running in the world. So it is, it's extremely prestigious to visit this place.
One notable triumph dates back to 1996, when the country completed the second-generation Super Kamiokande detector. At the time, it was among the largest neutrino detectors ever constructed, holding 50,000 tons of ultra-pure water that took 2 months to fill. Despite its smaller scale compared to the planned Hyper Kamiokande, Super Kamiokande still brought major insights into the nature of neutrinos. This facility's extraordinary achievements include findings on neutrino oscillations, evidence that these elusive particles change flavors en route through space. That revelation shook the foundations of physics and ultimately contributed to Nobel Prizes for researchers involved. This accomplishment catapulted Japan to the forefront of neutrino exploration and inspired even larger ambitions. Beyond Japan, other detectors worldwide have also logged impressive successes. Italy's Borexino experiment, while much smaller, famously provided the first confirmed detection of solar neutrinos generated by fusion in the sun's core. Meanwhile, the Ice Cube Observatory in Antarctica mapped neutrinos from across the Milky Way, offering insights about cosmic processes once thought impossible to observe. Each of these past breakthroughs demonstrates why scientists remain so hopeful about the new, bigger detectors. Building on lessons from earlier successes, Hyper Kamiokande aims to probe neutrinos like never before. With stronger shielding, tens of thousands of more sensitive photomultiplier tubes, and hundreds of thousands of tons of ultra-pure water, researchers expect to unearth fresh secrets about the universe. These previous victories serve as proof that, given enough perseverance, neutrino research can spark discoveries worthy of history books. Global Neutrino Research Race. Global neutrino research is a race that stretches across continents, with teams building giant detectors to study ghost particles. Japan's enormous project under Mount Nugo aims to hollow out an entire mountain and fill it with ultra-pure water, creating the biggest underground cavity for neutrino detection. With 560 researchers from 101 institutions worldwide, it reflects a broad coalition of expertise and resources. Yet this event is only part of a global surge in neutrino science. Italy's Borexino experiment found rare solar neutrinos, shedding light on nuclear fusion inside the Sun. Meanwhile, Antarctica's Ice Cube Observatory sits deep beneath a sheet of ice, tracking neutrinos that travel from far-off galaxies. Russia's Lake Baikal hosts an underwater detector that uses the world's largest freshwater lake to catch these elusive particles. Each region's unique geology or climate becomes an advantage. Mountains shield detectors from cosmic rays. Vast bodies of water amplify rare collisions. These global experiments work together, swapping data and findings, hoping to solve questions about dark matter and how our universe began. Number 20. Recovered satellite data reveals lost continent. As of January 2024, a satellite tracking website called Orbiting Now has reported over 8,377 active satellites orbiting the Earth. These satellites play a vital role in gathering information about our planet's clouds, oceans, land, and air. They also enable in-flight phone communications and play a vital role in connecting rural areas. However, an intriguing discovery emerged from a gravity mapping satellite. In 2018, researchers examining data from a satellite that had been inactive for 5 years stumbled upon remarkable findings that reshaped our knowledge of Antarctica's geological and geographical history. The discovery was made possible by the Gravity Field and Ocean Circulation Explorer (GEOCE) satellite, launched by the European Space Agency in 2009. Over 4 years, the GEOCE satellite meticulously mapped Earth's gravity field until its intentional destruction. Joe Rogan found it astonishing that this satellite contained gravity images that revolutionized our understanding of Antarctica. The new data provided further evidence that India, Australia, and Antarctica were once part of the same landmass called Gondwana, a subsection of the supercontinent Pangaea, over 180 million years ago. Today, remnants of this ancient continent lie hidden beneath Antarctica, presenting an unparalleled opportunity for exploration and the potential discovery of invaluable information. Number 19. Mystery of the Blood Falls, finally solved. Amongst the weirdest things that have been discovered in Antarctica, this might be the most shocking sight. The Blood Falls, mystery in the frozen continent's McMurdo Dry Valleys, has intrigued scientists for years. This crimson body of water, surrounded by white ice, has finally revealed its secret. Millions of years ago, as the Antarctic region changed, flooding occurred, forming lakes and pools. Cooling temperatures led to the formation of glaciers, trapping the water beneath layers of ice. Devoid of oxygen and isolated from the atmosphere, the water became rich in iron and highly salty. The iron oxidation in the brine, similar to rusting, gives it a striking crimson color. While the mystery of the Blood Falls hue has been unraveled, scientists acknowledge that much remains to be learned about the Blood Falls phenomenon.
Researchers also discovered iron-rich brine in the water, which oxidizes as soon as it makes contact with the oxygen in the air. This causes the waterfall to turn a red color.
Number 18. A wallet lost 53 years ago. You probably have lost your wallet at least once, but imagine losing it on a frozen planet with strange ties to Mars. Well, that's precisely what happened to retired Navy meteorologist Paul Grisham. After 53 years, workers on the White Continent contacted him, claiming they had found his wallet. So, how did it end up there? Let's go back over half a century ago when Paul was stationed in Antarctica during Operation Deep Freeze. From 1967 to 1968, he provided logistical support to civilian scientists on the continent. During the demolition of a building on Ross Island in 2014, Paul's wallet was discovered hidden behind a locker. Inside, it held items that captured moments from his life and Navy service, such as his Navy ID card, driver's license, beer ration punch card, and receipts for money orders he sent to his wife, among other things. Locating Paul, however, proved to be quite a challenge. The return of the wallet was made possible thanks to a group of amateur detectives who embarked on a weeks-long quest, exchanging emails, letters, and Facebook messages to track him down. When Paul was finally contacted, he was overjoyed. Interestingly, he couldn't even recall losing the wallet in the first place. He also shared fond memories of his time working on the icy continent. Number 17. 66 million years old fossil scientists sometimes encounter puzzling situations which seem to be devoid of logical explanations. Such was the case when researchers stumbled upon a fascinating reptile egg, estimated to be 66 million years old. Initially, the egg's true nature eluded them, earning it the nickname the Thing. Measuring 11 inches in length and 7 inches in width, it languished unidentified in Chile's National Museum for nearly a decade. Only recently, upon closer examination, did researchers realize its true identity as a giant egg, second in size only to the extinct elephant bird's egg. The egg is believed to have been laid by a mosasaur, an ancient sea lizard. The presence of nearby baby and adult mosasaur and plesiosaur skeletons suggests that the area may have served as a nursery. The egg's large size and delicate shell indicate unique reproductive adaptations associated with mosasaur gigantism. Scientists are still investigating whether the ancient reptile hatched on land or underwater, akin to modern sea snakes and turtles. It is truly remarkable how a single egg can unveil such revelations.
In 2018, a paleontologist suggested it might be an egg, but scans showed that there was no skeleton inside the egg. They tried to match it with a dinosaur's egg, but decided it wasn't. Then they suspected a link with mosasaurs.
Number 16. Rainforest and fossils. Speaking of signs of life, it's fascinating to consider that the Antarctic region was once home to rainforests. Given its current icy climate, it's hard to envision tropical trees and creatures thriving there. However, it is indeed possible. Before Antarctica became a frozen desert after the Ice Age, it was a warm tropical region teeming with lush rainforests. Some even speculate that civilizations thrived in this warm land until it was engulfed by ice. This theory gains support from the discovery of fossilized wood samples, tropical tree remnants, and leaf impressions, all of which provide evidence of past rainforests in the region. Additionally, scientists have unearthed numerous fossils of marine animals, birds, and even dinosaurs from the Cretaceous period, indicating a once warm environment. Furthermore, scattered fossils of a beetle species dating back 20 million years suggest a warm climate. These remarkable findings lead us to wonder if Antarctica might still conceal hidden rainforests, harboring unknown creatures, and possibly even civilizations within its depths. Number 15. Singing ice. In a surprising discovery, researchers in Antarctica stumbled upon a singing glacier. The expansive Ross ice shelf, which is roughly the size of France, emits an eerie and almost melodic sound. This unique phenomenon is a result of the winds sweeping across the snow dunes, causing them to collide and create vibrations that produce continuous seismic tones. Thus, the ice shelf is in a perpetual state of song. Although these sounds are not audible to human ears, scientists have utilized seismic sensors to listen to the haunting melodies. They describe the tunes as deeply sorrowful and melancholic, evoking a sense of terror. Initially, the singing was stumbled upon incidentally, as researchers were studying other behaviors of the ice shelf using seismic sensors. However, they have since realized that the song changes as the environment evolves. Consequently, they now employ the song as a means to monitor the stability and vulnerability of the ice shelf, keeping a close eye on any potential collapse indicated by alterations in the music's composition. This captivating discovery has raised intriguing questions about the possibility of glaciers one day producing songs that can be heard by human ears. Number 14. The Colossal Squid Expedition. The colossal squid is an incredible creature, known for its enormous size. It's believed to be one of the largest creatures in the ocean, growing over 46 feet long. The first specimens of this species were actually found in the stomach of a sperm whale back in 1925. But it wasn't until 2003 that a complete female colossal squid was discovered in the Ross Sea, measuring 18 feet long. This creature was once thought to be a mythical legend, but now an expedition is underway in Antarctica to learn more about it. The nonprofit organization Colossal is leading the expedition, using advanced subsea cameras and lighting systems developed by Subsea Imaging. They hope to answer important questions about the colossal squid, like its size, preferred habitat, breeding behavior, and the function of its massive eye. They're curious if the eye is used for offense, defense, or if it's attracted to light displays. They also want to understand how the squid uses bioluminescence. The timing of the expedition is significant, as it coincides with the 100th anniversary of the first discovery of the colossal squid in 1925. Number 13. A huge icefish colony. In the icy depths of Antarctica's Weddell Sea, scientists made an extraordinary discovery during a routine analysis of the seafloor. They stumbled upon an immense colony of fish nests, the largest ever observed. This sprawling nest covered an area of approximately 240 square kilometers, 92 square miles. The nests themselves were meticulously constructed, measuring 15 centimeters deep and 75 centimeters in diameter, with a distinctive arrangement of small stones amidst the muddy seabed. Each nest cradled anywhere between 1,500 to 2,500 eggs, often protected by an adult icefish. The research team, initially astonished, spent the following 4 days documenting an astounding number of over 60 million active nests. To put the size of this colony into perspective, it is nearly as vast as Orlando, Florida. This discovery holds significant implications for the local food chain, as these fish serve as a crucial food source for Weddell seals. Surprisingly resilient, these creatures have antifreeze in their bloodstream, making them among the hardiest inhabitants of this region of the ocean. Number 12. World's oldest pyramids. Imagine this. When we think of pyramids, our minds naturally wander to Egypt, with its warm climate and ancient pharaohs. But what if you find out that pyramids were once found in the unlikeliest of places? Antarctica? Yes, you heard that right. It turns out that a civilization once thrived in Antarctica, constructing pyramids to withstand the harsh environment of the region. Mainstream geologists have long been perplexed by how life could have possibly flourished in the extreme conditions of Antarctica. However, in 2016, scientists stumbled upon something intriguing. Satellite imagery captured a peculiar formation jutting out of the ice. Despite the remote and treacherous nature of the area, they believed it was evidence of a man-made pyramid. These structures had a striking resemblance to their Egyptian counterparts. But here's the kicker. The Antarctic pyramid is actually much larger than the Great Pyramid of Egypt.